Today we're going to do our notes on section 4.4, trigonometric functions of any angle. So this is different from the x and y sine and cosine relationships we saw before because these are for points that are not on the unit circle. Okay, so that's very important, the distinction between when it is on the unit circle and when it's not. So when we are looking for theta to be any angle in standard position, and the point P, x, comma, y is a point on the terminal side. R is the hypotenuse. Okay, it's the radius if that point was on a circle, and it's the distance from the point 0 to xy. So the six trig functions can be defined with the following ratios. Sine is going to be y over r. Cosine is going to be x over r. And our tangent is going to be our sine over our cosine, which is going to simplify to y over x. Okay, our cosecant is still the reciprocal of the sine, so it's going to be r over y. The secant is going to be the reciprocal of the cosine, so it's going to be r over x. And the tangent is going to be x over y. Okay, and in all of these, it's going to be important, right? We can't let x, y, or r be 0 if they're in the denominator. Okay, so let's look at our first example. We want to let the point P be -3, -5, and it's on the terminal side of theta. So first I'm going to plot -3, -5. Okay, in here, so this is my theta. Okay, but if we look at this, we have a right triangle. This side is 3. Okay, that's -3. This side is -5. So this, our distance, we're going to call r because it would make the radius of a circle, is going to be the square root of -3 squared plus -5 squared. Simplifying, that's the square root of 9 plus 25, which is the square root of 34. And the square root of 34 can't be simplified at all. So our sine of theta is going to be, I think of this just like our SOHCAHTOA. Okay, I always look at, I look at my right triangle, I look at my angle that's closest to the origin, and so my sine is going to be my opposite, or my y, -5, over my radius, my r, which I just found was square root of 34. Okay, and generally we want to rationalize denominators. Okay, my cosine of theta is going to be my adjacent over my hypotenuse, or using above, my x over my r. Again, we're going to rationalize. And then my tangent is going to be my y over my x, which is going to simplify to 5/3. Quickly, I can find my reciprocal functions. My cotangent is probably the easiest. because it doesn't have any radicals. Remember, I am going to look at this step and see that this can be negative square root of 34 over 3. And again, for my cosecant, I can take the reciprocal here, so I get negative square root of 34 over 5. Okay, take a minute and try the try problem on your own. I would suggest drawing in the coordinate grid so you can see where your point is going to lie. So here are your answers to the U-try. One thing I'm not sure I mentioned is that your R is always the positive value. Okay, so your R should always be positive. Your X and your Y, their sign depends on what quadrant they're in. For many of the problems that we'll be solving, it's important to know the sign. So whether it's positive or negative of your trig function. Okay, so one acronym to help remember this is all students take calculus. And let me show you what I mean. In our first quadrant, our sine is greater than 0, right? Because our y value is going to be positive. Our cosine is going to be greater than 0 because our x value is positive. And since both of those values are positive, our tangent is also going to be positive. Okay, in our second quadrant, our sine, right, our y value is still going to be positive, so our sine is positive. Our cosine will be negative, and our tangent, since our tangent is the ratio of the sine over the cosine, positive over negative is also going to be negative. So pause the video now and find whether the sine, cosine, and tangent are positive or negative for the last two quadrants. So hopefully you match me. In the third quadrant, you'll find that the sine and the cosine are negative. A negative divided by a negative makes our tangent positive. And in the fourth quadrant, our sine is less than 0, our cosine is greater than 0, and our tangent is less than 0. So that's this all students take calculus. All means that all of our trig functions are positive. Students, S stands for sine. So in the second quadrant, only the sine is positive. In take, T stands for our tangent. So in the third quadrant, only the tangent is positive. And calculus, the C stands for cosine. So in the fourth quadrant, only the cosine is positive. Okay, so again, all students take calculus. That's the acronym I learned. Any acronym that works for you will go. So for our example, this should be pretty quick. If tangent is negative and cosine is positive, name the quadrant which theta lies in. So tangent, negative. So our tangent is negative in our second quadrant or in our fourth quadrant. Okay, so that breaks down our options from 4 down to 2. But we have this and, so also our cosine needs to be positive. So our cosine in quadrant 2 is negative. Our cosine in quadrant 4 is positive. So the quadrant that has tangent negative and cosine positive is going to be quadrant 4. Okay, you try the next one. Pause the video now. Restart when you have the answer. Okay, so we were looking for when the sine is less than 0. So that was quadrants 3 and quadrant 4. And then we were looking for when the secant of theta was less than 0. So hopefully you remember that secant is the reciprocal of the cosine. And if the secant is negative, that also means the cosine is negative. So the quadrant that has sine negative and cosine negative is quadrant 3. Okay, let's move on to our next example. So we are looking for if tan of theta equals negative 2 over 3 and cosine theta is greater than 0, find cosine theta and cosecant of theta. Okay, so I am looking, this is my tangent is less than 0, okay, because my tangent is negative. If you notice, this is the same as the example above. So I know I am drawing in this point in quadrant 4, okay, and my tangent is always equal to y over x. So I have 2/3, and I know I have a negative, so I need to decide if I'm going to put the negative on the y or on the x. And because I know that this is going into quadrant 4, I am going to put the negative on the y. Okay, so I know I'm going down -2, I'm going right 3. Okay, because y is -2 and x is 3. So it's now asking for my cosine, which I know is x over r. So I don't have my r. So r is going to be the square root of 3 squared plus -2 squared, which is the square root of 13. So my cosine of theta is going to be x, which is 3, over r, which is square root of 13, which we can rewrite as 3 square roots of 13 over 13. Okay, I just rationalized the denominator. If you need to do that in an extra step, that's fine. Then I want to find the cosecant. So the cosecant is the reciprocal of the sine. I know that sine theta is y over r. So that means my cosecant of theta is r over y. So my cosecant of theta is r over y. Sorry about that. So it is square root of 13 over y is -2. We would usually write that as negative square root of 13 over 2. Okay, pause the video and try the you try problem. Okay, so hopefully the quadrant where tangent is negative and cosine is negative is going to be in our second quadrant. Okay, that's where my x value is negative, my y value is positive. So that's why I decided to put the -3 on the negative on my x and the positive on my y. So r I found using the formula, and I got square root of 10. And my sine is y over r, which was 1 over square root of 10. Rationalizing gave me square root of 10 over 10. My secant is my reciprocal of my cosine, so that's r over x. And my r was square root of 10, my x was -3. I moved the negative out front. As always, please come for questions, and please make sure you watch part 2 on these notes.